Well, let me record this session and then tell me what to click on here.
Okay, so I started with the intro to combining functions.
Okay.
I understood like the combining part, but then it asked me to evaluate this function, and I got really confused. So I wasn't really sure what to do after that.
So I should click on that and that'll show us the function.
Yep.
So how far down do I need to go here?
So let's see, go down a little bit more. So I understood all that. And then you go down.
Probably, I'm guessing right there.
Yeah.
Top row. All right.
Yeah.
When you have something other than x in the parentheses, is all you do is you take whatever it is and you substitute it for x.
Okay.
Okay, so that's how you evaluate functions when it's f of 2 or g of 2.
Okay.
So when you, in other words, f of 2 is 3, g of 2 is 4, so f of 2 plus g of 2 is 7. Tell me where to go to. At this point, I kind of need you to direct.
Okay, so actually it's right there, problem 1.
All right.
Right.
All right. First of all, what's f of x plus g of x?
Let's see. So it would be, so f of x plus g of x is equal to 3x, no wait, 4x minus 1.
Good. 4x minus 1. Let's see if it accepts that. These are always a little tricky. What do I need to click here? Enter?
So there's a check like right underneath it. So I think if you click off of the typing thing, it should.
Click that check. It was kind of hidden. Okay. All right. So that's simple enough. In other words, when you're adding polynomials, you add the like variables. We're adding 3x to x, and we're adding plus 2 to minus 3.
Okay.
Okay. All right. What's f of minus 1 equal to?
F of minus 1 is equal to negative 3 plus 2.
Give me a number.
Oh, it would be negative 1.
Okay. And what is g of minus 1?
That would be negative 4.
So what is f of minus 1 plus g of minus 1?
Negative 5.
Okay. Should we just go through these in order?
Yep.
Okay. Now, at this point, we're talking about linear functions. Okay?
Okay.
Everything is just x. It's not x squared. It's not the square root of x. When it's just x, it's a straight line.
Yep.
So that's what we're talking about is straight lines.
Okay.
This part is introducing you how to graph a line of a particular function.
Okay.
I don't know. Let's just test you. Let's practice and see whether you have any problems or not. Now, notice that the green line is the straight line. And that also is labeled y equals g of x. So the green line is g of x. And the blue line is a parabola, which means that's a quadratic, but that's f of x.
Yeah.
So we have a quadratic and a linear function here. Now, where's the solution to these two equations?
The solution to them is finding their slopes.
Where they cross.
Okay.
In other words, you can see my mouse. Right there they cross.
Yep.
And they cross right there. Now, neither one of those looks like a particularly clean number. They look like irrational numbers. They're still numbers, but they're not whole numbers or anything like that. Let's see what they ask. Which is the best approximation of f of 3 plus g of 3? Well, tell me what, we'll do the easy one first. What is g of 3?
G of 3 is, let's see, that would be 1. I'm actually not sure.
Okay, here's what we do. Here's the g function, the green line.
Yeah.
So we're going to go on the x-axis to 3.
Okay.
And then we're going to look at where that is on the green line. Well, it also happens to be 3. So that's what g of 3 is 3.
Okay.
What's f of 3? Do the same method for f of 3. F of 3 is the parabola. What is f of 3? Approximately.
It is approximately 2.5. No. Oh, wait, no, not 2.5. It's approximately 5. 3 and 5.
Look a little closer.
Let's see. 5 and so it's at 3, and then the y is at 5.
Actually,
it's 6. Yeah, it's at 6.
In other words, it's moving pretty steeply, so it's hard to tell the difference between 5 and 6 here. But it's actually crossing that grid at 6. So, in other words, they're not going to make this. When you look at a problem like this, you know that the answers have to be whole numbers, first of all. Because they're not going to give you a problem where it would be in between those grid markers. Because then you'd have to guess. They don't want you to do that. So they're always going to put these where they cross the grid lines. So this is definitely 3 plus 6.
Okay.
It's 9. Actually, you know, as much of a fan of Saul Khan as I am, that's the first time I've ever been on his lesson pages. I've watched a lot of his videos, his 10-minute videos, and I've referred hundreds of students to him, but I've never been on this kind of page where you have to input the answer. I've been on a lot of other sites that have always been difficult because they require the answer to be so specific. So I'm curious to see if Khan Academy handles it a little bit better. So far, so good.
Yeah.
All right, let's see. So you know how to subtract functions. Now, see where my cursor is?
Yeah.
The only difficulty with this subtraction is that negative sign that I'm pointing at has to be applied to both terms. So it becomes minus x plus 2.
Oh, yeah.
And that's how you get to the second step. And that's the problem that most people miss most often, is not distributing that negative sign to the second term. They distribute it to the first term, but a lot of people will give you minus 2 here. And then, of course, you're going to get the wrong answer. You can't have a sign backwards.
Okay, and then also on that one, would x just be equal to 0? Because I see that the answer is 5, and I know that like the three combining 3 and 2 would be 5. So would x? Oh yeah, wait, I see now because x cancels out.
Yeah, exactly. The x's cancel out and you end up with plus 5. So your answers don't always have an x in them, but they usually will have either a number or an x. The product, you know how to FOIL?
See.
Is that what you've been taught, Jonathan, is foiling?
I don't think so. That's not what I remember. But distribute the x.
Let's talk about this, because this is probably the most important part of algebra. How to multiply two linear terms together. Well, they haven't taught you FOIL. I'm almost reluctant to teach it to you because I don't particularly like it, but I'm going to teach it to you anyway.
Okay.
That stands for first, which is this times that.
Yep.
That stands for outside, which is this times that. That stands for inside, which is this times that. And that stands for last. The only thing left is that times that. Now, that's the way it's taught to most of my students, is FOIL. Now, I prefer ET, which is every term by every term. Notice that that's what I'm doing there. I'm taking the x, I'm multiplying it by both of the other terms, and then I'm taking the plus 3, and I'm multiplying it by both of the other terms. I'm adding them all together.
Yeah.
That's how I get to this step right there. The reason I prefer ET is because this works when you have 3 terms times 2 terms, or 3 terms times 3 terms. Whereas FOIL does not. FOIL works only when you have 2 terms times 2 terms.
Okay.
So the thing to remember is you got to multiply every single term on the left side in the parentheses with every single term on the right side. And add them all together. Okay? So that's how we get that comes from that. Usually the next 2 terms come from the O and the I. In other words, the outside is minus 2x. The inside is plus 3x. There you go. Minus 2x plus 3x gives you plus x. And then the last term is usually the last 2 terms multiplied together, which is minus 6. Notice that and this is important because you're going to get to factoring. And in order to truly understand how to factor, you got to know how to multiply. Because what you're doing when you're factoring is this in reverse.
Yeah.
In other words, if I give you this and I say factor it, you got to be able to turn it back into those 2 terms. X plus 3 times x minus 2.
Okay.
Okay? So that's why foiling is pretty important. At least, calling it FOIL is fine as long as you have 2 terms times 2 terms. And that's what you're going to be dealing with for quite a while, I'm sure. Once you get to 3 terms times 3 terms, then use ET. Okay. So, whoops. Notice that the quotient is merely f of x in the top, g of x in the bottom. And that is not simplifiable. That is the final answer where my finger was pointing. In other words, you cannot cross out those x's. If it's not exactly the same binomial term, you're not going to be able to cross it out.
Okay.
All right.
Okay, so
here, let me first of all bring this up so I can write. I'm going to have you give me the answers. What is P of 3?
So P of 3 would be 5.
What is Q of 3?
Q of 3 would be 2.
And what is R of 3?
R of 3 would be 3.
And then it's subtracting P of, is that P of 3 or P of 0.3? I can tell with a piece of dirt on my screen.
Yeah, it's P of 3. That's what I see.
P of 3. Okay. What's P of 3 again?
P of 3 is 5.
Okay. What's all that equal to?
Shut up. 1 sec. Let me get the dog out.
Okay.
That all equals 25.
Okay. And that's what we want to put in there is 25. That's a big dog. That is not a little dog. I recognize big dog barks. So does my dog. So does my dog that's sitting on the chair next to him. She hears that bark.
Yeah.
All right. Let's see. Do we need to go to next video?
Yeah, I guess. Then should we just go to like the next lesson or no?
Let's try that because this looks like an instructional video.
Yeah.
So what do we need? We're going to do adding functions now. Well, this is about the easiest thing there is adding these things. You just add like terms. Whoa. It knows my name? Is that accidental that it says David? No, that's David Huffman. So these are all question and answer.
Yeah, so I think I see the lesson 1. It's so you'd want to go below the subtracting video, and there it is. So click on that, I think.
Below the subtracting video, this one right over here, adding and subtracting functions?
Yep.
Okay. We just did the subtracting, or?
Well, that one's a video, so I guess.
Okay.
Want to just do this.
I'm beginning to understand.
Yeah.
Okay. So let's go down to the first problem. All right. So here they're not going to give us the function.
Okay.
Okay. They're just going to tell us that it's f of x and it's a straight line. That's what, in other words, they're just going to tell us that y equals f of x and they show us the graph of it. That's the green line. And they also show us y equals g of x and they show us the graph of it, and that is the blue parabola.
Okay.
And then y equals f plus g of x is the graph on the right, which is the orange. In In other words, if you add these two functions together, you will get a function that is the orange function. Now, you don't have to figure that out in your head. Just imagine you know that the f of x function is linear, so it's like x plus 5 or x plus 1. And you know the blue function is quadratic, so it's like x squared something. So if you add them together, you're going to still end up with x squared plus something. So you're still going to end up with a parabola. But that's all you end up with, is you don't no longer have the straight line. So you end up with a parabola. Okay? So that's the first thing to kind of understand.
Yeah.
Now, all right, so this is still sampling. Evaluate each expression. What is f of 1?
So f of 1 is... So wait, are we going off of the graphs or the equation?
Yeah, absolutely, because we don't have the functions. They didn't give them to us.
Okay.
In other words, the only way to answer these is off of the graphs. Sometimes that's the case, and that's what the purpose of this is.
Okay, f of 1 is 2.
Okay, if I go to 1 on my x-axis, that is 2. Okay, what is g of 1?
4.
And what is f plus g of 1?
That is 6.
I think you understand it. Okay. Now notice here we have two different functions. One of them is quadratic and the other one's quadratic.
Okay.
So, add the two of them together. That's what a plus b of x means.
So it would be 4x squared plus 3x.
Hold on a second. I gotta make sure I know how to input this. I guess 4x squared is that. Okay, I'm sorry, what? Plus 3x? And then I would go to the right. Okay, plus 3x.
Minus 8.
Don't see a check. Oh, it's at the bottom. I see now. Yeah, how it works. Okay. What is a plus b of negative 1?
Okay, so...
First, and tell me how you're going to do it.
So what I'm first going to do is I'm going to substitute all the x's for negative 1.
From which function or functions?
From a and b.
Actually, the only one you have to substitute is that one right there.
Oh, yeah. So,
in other words,
that would
you can now ignore a and b. What you're interested in is what is a plus b. So you're going to substitute negative 1 in for the x's of the a plus b function.
So that would be 4 minus 3 minus 8, which then would, if you combined all of those, would be, so 4, so that'd be negative 7.
Okay. Oh, I didn't check that either. Okay. Subtracting is pretty much the same as adding. The only thing is that people have a harder time subtracting than adding, especially when there are multiple terms. So I'm going to put this up so I can write on it. Yeah, I just realized I don't need to. This is an example problem. But notice what the problem is going to be. Q minus P is going to be Q of T, which is everything that they have here in parentheses, minus the other function, both terms, in parentheses. Can you see where I'm pointing, Jonathan?
Yeah.
Okay. So the key here is that this negative sign that I'm pointing to, that has to be applied to both terms. So the first set of parentheses, I can just take away. It doesn't change anything. The second set of parentheses, very important that I change the sign on every term that's inside those parentheses. So you just remove the first set of parentheses and you get these first three terms. And then the negative sign applies to the 2t. And the negative also applies to the negative 1, making it positive 1. That's where everybody goes wrong. Is the mistake that everybody makes here is putting a negative 1 there. Mm-hmm. Okay? So that's the only thing to really remember there. Okay.
Okay.
Here we have two different functions, j of n and k of n. Tell me what j minus k of n is.
Okay, so it would be 3n cubed.
No. Oh, excuse me. I didn't notice we were dealing with cubes here. Very good.
And then minus 9n squared. Plus 3n. Oh, yeah, plus 3n.
Yeah. No, you got it.
And then plus 3.
How come it doesn't let us check that? It forces us to do all... Oh, there it is. It just took a while to come up. My checkbox wasn't... Oh, darn. What do we do? Ah, we were subtracting. And it's j minus k. So the 3n cubed is correct. And then we got minus n squared minus 8. Aha! There's our problem right there. Let me draw here. This is why I really emphasize those basic arithmetic skills, because that's all algebra is. I don't know if you've noticed it or not, but every single problem is just a series of multiplications, additions, subtractions, and sometimes divisions. Mm-hmm. Okay? So, here's what we have. First of all, I've got that minus however many n cubed we have. So that gives me 3n cubed, because there's none in the k function. But then I got minus n squared minus a minus 8n squared.
Oh, I see.
What's that?
So that would be 7n squared.
Plus 7, yeah. So let's go back. I think that's probably our only mistake. The 3n, aha! How many n's do we have in the j function?
So we have no, just n's.
And we're subtracting the k function from the j function.
Yeah.
So it's going to be a plus or a minus down here?
It's going to be a minus.
Yes. And then we have 8 minus a minus 5.
So would that instead be plus 13?
Uh-huh. All right. Yeah, you got to be really careful with your signs, particularly when you're subtracting. Subtraction, 90% of the errors you're going to make are going to be in subtraction, not addition. Subtraction is just harder. You just got to get used to doing it. And most people hate it so much that they start dropping negative signs just to avoid it. And that's the worst thing you can do. Obviously, you're going to get the wrong answer if you drop a negative sign. You can't drop. I could not drop. This was 8 minus a minus 5. If I drop one of those negative signs, I'm dead.
Yeah.
Okay, here's two more functions.
Okay.
Yeah, we can do this one on the fly, I think. We want, it's very important the order here. We don't want g minus h, we want h minus g.
Yeah. So then if we distributed...
Hold on. Let me write this function out first, and then we'll evaluate it. I just realized that was a different kind of problem. Okay. So what is h minus g equal? Just h. How about h of x minus g of x? Tell me what that is.
So g of x, instead of it being 4x squared minus 7x plus 2, it would be negative 4x squared plus 7x minus 2.
Yeah. In other words, basically what we're going to do is this. And use parentheses around the first term, although they're rarely needed. They're always needed around the second term, as long as you're subtracting. If you're adding, they're not even needed around the second term. But usually you're subtracting, because that makes the problem harder. So, what's my answer?
So the answer would be, well, if you then also
Start with the highest degree polynomial term first. In other words,
okay, so it would be,
squares do we have?
yeah, so it'd be negative 4x squared.
How many x's in total do we have?
In total, we have 2.
Okay, well, what do they total?
They total. Oh, I get it now. Okay, yeah. They total 9.
Plus 9. I need the plus sign here because this is part of a polynomial.
Mm-hmm.
In other words, I can't not write the plus sign. And then finally, what's the total of the numbers?
Minus 7.
Okay. All right. So it's minus 4x squared plus 9x minus 7. Minus 4x squared plus 9x minus 7, correct?
Yeah, but don't we want to put 3 in, substituting?
Yes. I apologize. Yeah. I knew there was something different about this problem. So, okay, I won't erase that because that is our h minus g function.
Mm-hmm.
So now tell me what h minus g evaluated at 3 is.
So that would be negative 36
Okay.
plus 27
Which is
minus
what?
7.
Let's do that one step at a time. What's negative 36 plus 27?
That is 9. Negative 9.
Negative 9 and then minus 7.
That would be negative 16.
It's a funny problem because that's the problem I always give to students. That's the hardest problem for everybody. Is -9 minus -7, or rather -7, or -7 minus 9. That's what everybody has troubles with. All right. Okay, so now we have an application of functions where we have a dependent variable and an independent variable. In other words, the number of men can be modeled by this function over here on the left, where T is the number of years since 1980. And the number of women can be modeled by this function over here, and T is the same thing. It's the number of years since 1980. So if we just think about this for a second, if it's 1980, what is the number of men in this college?
Number of men in this college, 526.
Okay. How about women?
474.
Okay. If it's 1985, how many men are there getting bachelor degrees?
That would be 21.
521, okay.
521.
And the number of women?
That would be 484.
Good. So that's what functions are all about, where you have two variables, basically. You have the number of men, or the number of years that have passed, and that's going to tell you how many men have received degrees. It's also going to tell you how many women have received degrees. So they're asking us, what is the total number of students receiving bachelor degrees at that college, T years since 1980. They don't want a number, incidentally. Notice that they don't specify what the current date is. This might have been written in 2005, whereas it's 2018 now. So the answer must be a function of T. So what is it going to be?
So it's going to be 1,000 plus T.
Good. In other words, you're just going to add those two functions together. And just to get in good habits, I'm going to put the T first. Because normally when you're talking about polynomial equations, you want the variable first. Now, it would have accepted it either way. I could have put in 1,000 plus T, and I'm sure it would have accepted it. But just for habit, when you're writing a polynomial, I mean, when you get higher degree polynomials like quadratics or cubics, put them in order of the power. If you have a T squared, it goes first. Then the T, then the number. If you have a T cubed, it goes first. That's a nice function. This is the sine function, the purple one. I don't know how much trig you've had, but that's what that is. That's what g of x is the sine of x. And the green function is just a linear function. In fact, that's about the simplest function you get, which is y plus x. Excuse me, it's y equal x. Notice that the slope on the green function is 1. What's the standard equation for a... Let's talk about this a little bit, just because it's really important. What is the general equation for a linear function? Y equals what?
Y equals mx plus b.
What is b in this case?
B is 0.
So now we have this. What is m?
So y equals, that is 1 over 1. So it's just 1.
So this function is y equal x. Now, this other function, this one, I kind of recognize that as being y equal sine of some number times x. In other words, it's not quite sine of x. Its period is 8. So it must be, let's see, the period equals 2 pi over b. So b equals 2 pi over the period. The period is 8, so it's pi over 4. So this thing is y equals sine of pi over 4 times x. So that's what this function is.
Okay.
Now, whether I needed to do all of that or not, I don't know. I just did it for your... At some point, you're going to have to do all of that.
Mm.
Maybe not here, because which is the graph of f plus g of x? Let's get as much of it as we can. First of all, since I don't have a big enough screen, let's take is A it. And how do you tell?
Let's see. I'm not really sure how you tell, but right now the slope.
You're not going to be able to tell by slope.
Okay.
But what you will be able to tell is adding the two. Because that's what they're asking us to do, is add f plus g. So if I told you, what is f plus g of 2?
So
what's
f plus
what's f of 2?
F of 2 is 2.
No, it's 1. Oh, excuse me, you're right. What is g of 2?
It is 1.
So what is f plus g of
3?
2. Okay. So we know that f plus g of 2 has to be 3. Well, that point's right. Let's check another point. What is f plus g of 4?
F plus g of 4 is, so let's see, 0 plus 4, so it's just 4.
Okay, that point's right. So far, my money's on A.
Yeah.
Now, if I scroll down, obviously B does not work.
Yep.
So if we only have 2 choices, but that's how you do it. In other words, you don't really need to know what these 2 functions were. In other words, I didn't need to know that that was y equal x or that that is y equal pi over 8x.
Okay.
It's irrelevant to the solution. So all we had to do is add the 2 y values together of each function at a particular point and make sure that it agrees with this function that they came up with. Because it's hard to tell. When you look at these 2 graphs, it's not easy to add them in your head. It just isn't. And it's not easy to look at these graphically and figure out which is the correct answer. But if you test some numbers, then you can certainly rule out one of the answers. In other words, notice that I only checked 2 points. the only way I know this is the right answer is to check every point, which you can't do.
Yeah.
So the way to figure these out is to find a graph that doesn't match. And we already figured out that f plus g of 4 should be 4. And if we go down to this curve, f plus g of 4 is 0. So we can disprove b in one step.
Yeah.
Kind of an important point in geometry, if you remember, is that when you're proving stuff, the easiest way is to disprove stuff. If I can find one point that does not match on graph B, then it's not the correct graph. I checked 2 points on graph A and both of them fit. So I was pretty sure it was correct, but really what I needed to do was check both of those points on graph B. And one of them does work. If I were to check the point 0, well, either graph gives you the correct answer, which is 0. But when I check the point 4, second one doesn't work. So I immediately know it's wrong. That makes the first one right. Because there's no really way to prove all of them, all of the points. You can't test all of the points.
Yeah.
So let's see. I guess I need to click on multiplying functions. No, that's a video. How can I tell the difference between the videos and the C9 lessons, I guess? Let's try that.
So the videos have like the play kind of YouTube little thing.
We don't want to do that.
The lessons look like they are a piece of paper.
Right. That's what we want, is the lessons. I don't think I found them is the problem. Let me back up a page. Maybe you can help me find them. What the next step is.
So it's the one at the very bottom of the thing. So it's multiplying
the transcript. Yes? No? You know?
No, it would be, so go to the left, over by the little tab that has the So go up a little bit.
Okay, I'm looking into the. You can see where I'm at. Which one should I click on?
Go to multiplying and dividing functions.
Okay. There we go. How can you tell which one is a video and which one is text?
So if you look at the small little icon right by it.
Text. It's a piece of paper, and the other is a play sign. Now I get it.
Yeah.
All right. So when you're multiplying stuff, you want to use FOIL. Notice that this first example is a linear term, 2x minus 3, times another linear term. Both of them are binomials. So we're going to multiply every term by every term.
Okay.
Okay, and we get down to that as our answer. In other words, when you do FOIL on these two, you get this, and then you're always combining the two middle terms. You're never combining that far left term or the far right term. And when you combine the two middle terms, you get this. All right, let's do some practice. When's your school start, Jonathan?
The 17th.
Oh, not until next week. Okay. So that must be all of Jefferson County is next week.
Yeah.
Okay. So here, let's do it this way first. So we got 3y minus 4 times 3 minus 2y. Every term by every term. What do you get?
So that would be 6y squared.
Hold on. Always use a certain order on these.
Okay.
Don't jump around. And there's a
So
reason for that. In other words, you just did the L of FOIL.
Yeah.
Let's do the F first. What's
Okay,
the first?
so would it be negative 12?
No, the first term is the first two terms. That's what it means. That's what
Okay.
the F means.
So it would be 9y.
Okay. The outside, that's
that would be,
what it means.
so that would be 6y
I need a sign.
squared.
It's minus 6y squared. And what's the inside?
It is negative 12.
And the last.
The last is negative 8y.
Positive. It's negative 4 times negative 2.
Oh, it would just be 8y then. Yeah.
Right, so it's plus 8y. Now,
Yeah.
I don't care at this point that it's out of order.
Mm-hmm.
The main thing I'd much rather do is stay in the order of FOIL. Okay? Now I can rearrange this. So
Yeah.
what's the final answer going to be if I put it in proper order?
It would be negative 6y squared plus 17y minus 12.
And that should be our answer. And I'm looking at this. Before we answer that, let's answer that one. So what is that?
So that
And
is,
all you have to do is plug it into that one right there.
okay. So that is, wait, but there's different, like, evaluations. So would that mean anything
So
on
here's
it?
what we're going to do. We're going to do it one step at a time. For y, I'm going to plug in minus 1.
Okay.
For this y, I'm going to plug in minus 1. There's no y over here. Now,
Yep.
simplify that.
Okay, that's, so 6 minus 17. Oh yeah, so it'd be,
Hold on, do your exponents first. What's negative 1 squared?
1.
What's 1 times negative 6?
Negative 6.
What's that?
So that's negative 17.
Minus 12. Well, what is all of that together? You basically can add all three of those numbers and they're all going to be
They're all going to be 35.
right. Negative 35.
Yeah.
So our two answers that we want are that one and that one.
Yeah.
Now, let's see if I can remember that. Minus 6y squared plus 17y minus 12 and negative 35. Okay, minus 6y squared. Whoops. Jump down. Jump way down on me. Minus 6y squared. What was the rest of it?
And then wasn't like negative 9. Oh yeah, so it was negative 9y and I think and then 17y. So that would be negative 8y. No, that would be 8y.
I think it was, let's see, I'm looking at 9y, and I'm looking at plus 8y, so it's plus 17. Y. And then the two numbers are minus 12. So that should be that one. And, oh, takes a while for that check to come up.
Yeah.
Always think, and this was minus 35, if I remember right. Ooh, wrong. What do we do?
Oh, I see. So it's mx is equal to x squared minus 3x.
Oh, it's a different thing altogether. I thought it was the same C and D function.
Yeah.
Okay. So first of all, here, let me get my writing board up here again. It's a little tricky, but so what's m times n of x? In other words, let's start from this position here. X squared minus 3x times x minus 5. Now, because this is a quadratic, doesn't really matter. It's still a binomial term. In other words, there's only two terms in that polynomial on the left side. So we can use FOIL.
Okay.
FOIL it.
So it would be x cubed minus 5x squared.
It's just best to do these one step at a time and then simplify, rather than trying to do those two middle steps at once in your head.
And then, so then it would be negative 3 minus 3x squared plus 15x squared. I'm not squared, just x.
Just x. Okay, now combine everything. We only have one of those. We're only going to have one of those. So the only two terms we need to combine are those.
Mm-hmm.
What is it? What is that?
That is negative 8x squared.
Okay. And now let's evaluate it at minus 1. So
Okay, so that would be.
And this will be the last one we do here. I just looked at my clock. I realized I got you over a little bit of time. This is always the best way to do it particularly when you have negative numbers. If you don't do this step right here, it's really easy to make a mistake.
Yeah. Okay.
Now simplify. What's minus 1 cubed?
Would be negative 1. Then minus 8 minus 15.
Which is?
And then all that combined would be negative 24.
Okay. All right. That's a good place to stop, Jonathan. Yeah, well, your skills are still there. You haven't eroded much. You're pretty good on this.
Okay.
We have a session scheduled for tomorrow, same time?
Yep.
Okay, I'll talk to you then.
Okay.
Bye-bye.